All right, guys, we're going to continue along in section 2.5, section C. When we read a graph to determine if it's increasing or decreasing, we're going to read the inputs, or x values, from left to right. So, if we have increasing and decreasing functions, we have an interval of I that is a subset of the domain. X sub 1 and x sub 2 are in that interval, and x sub 1 is less than x sub 2. So x sub 1 chronologically is going to sit on the left of x sub 2. A function is increasing on that interval when the value of the function at x sub 2 is greater than the value of the function at x sub 1 for all the x sub 1 and x sub 2 in that interval. So basically, the larger inputs produce larger outputs. The function is decreasing if the value of the function at f of 2 is less than the value of the function at x sub 1. So the larger the inputs produce smaller outputs. And lastly, the function is a constant on that same interval if the value of the function at x sub 2 is equal to the value of the function at x sub 1. The larger the outputs produce identical outputs. So it does not change over that interval. So if we're looking at this next one, we want to use this graph. We're going to figure out where it's increasing, decreasing, and or constant. So we're going to have different subsets to this answer. So the first one we're going to do is when we have f of x is increasing. That's going to be for all the values of x in the intervals when it's going up. So looking at this first one, we're going to see that it's going up all the way from, I'm not going to be able to get this nice little highlighter pen. It's going from here to here, going up. So that's going to be all the values when x goes from 2 all the way up to 3. Next we're going to figure out when f of x is decreasing. It's going to be for all the x's in the intervals when your graph is moving down. So if we're looking when the graph is moving down, it starts here and goes down to here, and then that point down to this point. So I want the values from wherever that x value starts, which if you're reading from left to right, it's all the way going left to infinity, all the way up to this point where it stops here at x is equal to -2. So from negative infinity all the way up to -2, and then all the way from the points of 3 continuing along to infinity. And then the last thing we want to do is figure out when f of x is constant. That means the values are not changing over the graph. So we're looking for all of the x's where the values do not change. It's all of these points in the middle. So we're looking at the points going from this starting point when x equals -2 all the way up to this ending point when x equals +2. We're going to skip down to the next section where it has a little bit more vocabulary. We're going to do the end behavior of the graph is the direction the end is pointing. We look from left to right. So we're looking from negative infinity or positive infinity to determine if it's pointing up or down. So if we look at the last two examples, the first one had this graph that was decreasing and then constant, a little increase and then decreasing. So if we look at the end behavior, you're going to describe up or down on the left and up or down on the right. So this one on the left side is pointing up. And if you're looking at the right side, it's pointing down. If you look at the second example up there, we're going to do that one in class, and we can do that one in class for the describing of the behavior also. So that's it for end behavior and determining when it's increasing, decreasing, or constant.